So this video is a continuation on the introduction to biochem. So apart from what we've discussed from the previous video, acids, bases, and buffers are important in biochem. So as you know, inside the body we have natural buffers. Okay, so the purpose of those buffers is to resist the changes in pH para ang reactions, because the reactions in the body class needs enzymes, diba? Almost all reactions, all biochemical reactions needs enzymes, and these enzymes are highly pH sensitive. So if the reaction causes a change in pH, then most likely the enzyme might be denatured. So dili na mo function ang enzyme because those enzymes are pH sensitive. So we have natural buffers in the body para dili ma-change ang pH sa system or sa atong body. Now, in the lab, we also try to mimic these reactions. So kung i-mimic na tong reactions, we also have to mimic the buffers inside the body. So we also have to resist changes in pH if we do these reactions in vitro. Now, ang concepts involving buffers, to understand those concepts, we have to know acids and bases first. So we have several definitions of acids. So we have the we have the Arrhenius acid and the Bronsted-Lowry definition. So an acid class is any ionic compound that releases hydrogen in solution. So this is the Arrhenius concept, and according to Bronsted-Lowry, and acids are proton donors, or H+. When I say H+, it's called proton. H+ donors, and bases are H+ acceptors. Okay? So it means proton donors, acids, and bases, proton acceptors. So when I say proton, it's just H+, okay? So according to Arrhenius pod, this is the Bronsted-Lowry nga definition, okay? And ang Arrhenius definition is that an acid is any ionic compound that releases H+ in solution, whereas a base is any ionic compound that releases hydroxide ion in solution. So meaning, if you have an acid class and you dissolve that in water, okay, remember in aqueous solution, you dissolve that in water, if it releases hydrogen ions, then that substance is an acid. For a base, if you have water, if you dissolve a base in water, if it releases OH, it's a base. Okay? So another important characteristic of water is that, let's go back. So for example, class, you have HCl. Now, you know nga HCl is an acid, diba? If you dissolve that in water, you have H+ and chloride ions in aqueous solution. Meaning aqueous, it's dissolved in water, okay? So what's actually happening, class, is that what you have in the solution, what you have in the beaker, na imong gidissolve, you don't have intact HCl anymore. You only have H+ ion and chloride ion. Now, this H+ nga ion is what measures the acidity of that solution. Mao na ang pH, mao na ang gi-refer sa pH. It's the concentration of the H+. Kung pila sa HCl ang na dissociate into H+ o chloride. So mao na ang nag-determine sa acidity of the solution. Okay? Now, that is the reason why HCl is called a strong acid, because all of the HCl, kung i-dissolve na nimo siya sa water, ang tanang HCl will be dissociated into H+ and Cl-, or hydrogen ion and chloride ion. Okay? Now, if we compare that with acetic acid kanang nasa vinegar, di ba? Acetic acid is a weak acid. So, what it means is that when you have acetic acid dissolved in water, what you have in the solution, what you have in the beaker, will be acetic acid, intact na acetic acid, some of this acetate ion, and some of this hydrogen ion. So meaning, if for example, if ang imong gi-compute pag prepare is you computed for 1 molar of acetic acid, what you have actually in solution, kung i-dissolve na nimo sa water, when you already have the solution, this 1 molar solution, you don't actually have 1 molar. You have approximately 1 molar of acetic acid because, well, this is less than 1 molar because some of these acetic acid have been dissociated into acetate ion or hydrogen ion, but only a very few amount. Very little amount, okay? So that's why it's still approximately 1 molar. It's basically still almost all acetic acid. But it has released a little bit of H+, which makes that solution acidic, which makes acetic acid in solution acidic because it was able to release hydrogen ion. Bisan pag gamay ra kay na siyang hydrogen ion. This is the reason why acetic acid is called a weak acid because you form small amount of H+. Okay? So, mao na ang nag-determine sa strength of the acid. Unsa kadaghan nga ma-release niya nga H+ in solution. Okay? Now, this is also the reason why only weak acids have reported Ka, meaning it's the acid dissociation constant. Kay, if you report K, it's useless to report Ka for for strong acids kay ang tanan baya mo dissociate into H+ o chloride, di ba? So it's useless to report acid dissociation constant because we know nga if strong acid siya, all of these will be dissociated into H+ o chloride. That is why sa table in appendix of books and literature, you only have reported Ka values for weak acids and weak bases. So it's the same thing for bases. So, ang strong base class are those that produces OH directly. So, for example, NaOH is a strong base. In aqueous solution, ang NaOH, it dissociates into Na+. Okay? Sodium ion and hydroxide ion. Okay, so this hydroxide ion is what determines the basicity of the solution. Now, in solution, you don't have NaOH anymore. All of them have been dissociated into Na and OH minus. That is why NaOH is called a strong base. If you compare that with ammonia, you actually form NH4 plus and OH minus. Now, take note nga, even the hydroxide ion, it produced hydroxide ion, but even the hydroxide ion came from water. Okay? Came from the ammonia reacted with water. Diba? So, in here class, ammonia here is a weak base. Okay, now, you have a weak base. So, as you notice, ang ammonia dire, nihimo siyang NH4+, diba? From NH3, nahimo siyang NH4+, which means that ammonia here accepts hydrogen ion, which means it's a base. It acts as a base. Now, ang water here is what donates the H+. So, nahimo siyang OH, di ba? Because it donated H+, which means ang water here acts as an acid. Okay, it's an H+ donor man. This is what you call as an acid-base reaction. Because you have a base and an acid. Now, compare that with this one, weak acid. So, H+, it's actually also H3O+. So, H+ is the same as H3O+. Okay, so ang difference na niya is that gipunan ra ni mo water molecule. So, it's a water molecule nga gi-attachan og H+. Okay, but it's the same. These two are the same. Okay, so if you compare that here, ang CH3COH, this acetic acid, acts as an acid because it donates H+. Diba? Nahimo siyang CH3COO. Meaning, gidonate niya ang H+, padung sa water. Diba? Ang water nahimong H3O+, from H2O. which means that water here acts as a base because it's a proton acceptor. It accepted H+, which means that it acts as a base, diba? So, you also have an acid base. Now, take note that water here acts as a base, whereas water here acts as an acid. This gives us an important characteristic of water, which makes water as an amphoteric molecule. Amphoteric meaning it could act as an acid or it could act as a base, depending kung unsa iyang kuyog sa solution. So, in fact, if you have just water, kanang water lang, one water molecule acts as an acid and one water molecule acts as a base, forming this one and this one, H3O plus and OH. It comes from two water molecules. Now, meaning, di ba water is neutral? So, if you just have water, meaning you have an equal concentration of hydronium or hydrogen ion. It's the same, hydronium and hydrogen. So, whenever I say hydronium, I mean hydrogen. And whenever I say hydrogen, it also means hydronium. Okay? So, it means you have an equal concentration of hydronium and equal concentration of hydronium and hydroxide ion, which makes water a neutral substance. Neutral meaning it has equal amounts of H plus and OH. Now, kung mas mudaghan na ganina ang H plus, that means it's already acidic. Kung mas mudaghan po ang OH, it means that that is basic. So that is why acids and bases, they neutralize each other. So here, we have the pH. As you know, pH determines the acidity and alkalinity. Alkalinity or the basicity of a substance. So, the acidity of a solution is measured by the concentration of hydrogen ions. Okay, so, if we go back here, class, this dissociation, pareho sa acid, if acid has Ka, water has Kw. So, all of these are equilibrium constants. Pareho ra na sila, they are constants, but they have specific names. Ang kinirang mga subscript are specific names. So, this is the ion product constant of water. So, the ion product constant of water, class, is Kw H plus times the OH. And this is equal to 1 times 10 to the minus 14. 1 times 10 to the minus 14. You have to remember this value because this is a constant. You have to memorize this. This is not given in any problem, any exam. This won't be given because this is a known constant of water. Which means that if Kw is 1 times 10 to the minus 14, in water, because in water we have equal amounts of H plus and OH, diba? We have equal amounts. This means that H plus concentration in water must be 1 times 10 to the minus 7. And the OH concentration must be 1 times 10 to the minus 7. Because equal man ang amount, kay neutral man ang water, diba? So, 1 times 10 to the minus 14 should be equal to 1 times 10 to the minus 7 times 1 times 10 to the minus 7. So, you have to multiply the concentration. You get this, diba? Okay? Now, if you notice, tag-as kayo, diba? It's very tedious. I mean, not really tedious, but it's kanang inconvenient to say the concentration of H plus or the acidity of the solution has a concentration of H plus concentration which is equal to 1 times 10 to the minus 7. Diba? It's very long. That is why we created this pH measurement. So, pH class is, it's like an operation. So, for example, it's like we have 3 times 4. When you see this kining X, it's an operator, diba? This, when you see X, this X nga sign, this operator, it means the operation of this one is to multiply. It means to multiply 3 by 4. That's the operation of this operator. Now, if you have P class, if you have pH, for example, this P is an operator. This operator means ang operation ani is to take the negative log. The negative log, which means if you have pH, it means to take the negative log of the H plus concentration. If you have POH, it means to take the negative log of the OH concentration. If you have pKW, it means to take the negative log of KW. Okay? KW. So, it's just an operator. Now, because it's negative log, take note nga, ang negative log class is, because it's negative log ba ka nang, if dako ang value sa H+, gamay ang result sa negative log of H+, because it's negative log. Okay? So, that is why ang pH range na to, kung acidic, di ba ang acidic, it has high pH, high H+. If basic, meaning gamay ang H+, di ba? So, that's why ang pH na range na to, if you have acidic, meaning if dagko ang H+, you have 0 to 6 nga range. Nasa ubos, gamay ang pH range, di ba? Compare that to basic nga, gamay ang H+, but dako ang pH. It's because of this negative log na function. Okay, so you should not forget that. Okay, usually this is the kanang common na honest mistake of students. Now, another thing that you need to note of this pH nga measurement is that it is a log nga function. Remember nga log nga function is to the base 10. It's 10 raised to the power of something. Diba? That's the logarithmic function. That is what log means. Which means that if you have one change in one unit scale, meaning from 1 to 2, or from 2 to 3, or from 3 to 4, it means a tenfold change in H+ concentration. Okay? So, this is what it means, class, the logarithmic na pH scale. So, if you have pH 1, meaning, if you have pH 1, that's Kw equals H plus times OH. Diba? So, that means if you have pH 1, because this is constant, this is always 1 times 10 to the minus, this is always 1 times 10 to the minus 14, this Kw. Bisan pag acidic, neutral, or basic na imuhang solution. This is always a constant. So, ang magvary ra are the concentrations of H plus and OH. So, if you have pH 1, that means ang concentration sa imong H plus is 1 times 10 to the minus 1. Diba? Because pH is equal to negative log of H plus. So, that's, if ang pH is equal to 1, you only need to calculate for this one, negative log of H plus. Diba? You need to calculate the H plus concentration. So, if you solve that using a calculator, given ka o pH 1, the concentration of H plus is actually 1 times 10 to the minus 1. Or, if dili ka mo gamit og scientific notation, it's the same as 0.1, di ba? This 1 times 10 to the minus 1 is the same as 0.1. So, if you change the pH to 2, you have 1 times 10 to the minus 2. Ang concentration ana is 1 times 10 to the minus 2. Or, this is equal to 0.01. Now, take note of the change of the hydronium concentration. That's 0.1, this is tenths, and this is tenths, hundredths. That's from tenths to hundredths. This is a tenfold change in H plus concentration. So, if you have 2 to 3, tenths, hundredths, thousands, so from hundreds, it's now in thousands. Diba? So, it's a tenfold change in H plus concentration. That is the effect of logarithmic. So, if you have from pH 7 to pH 8, it's actually already a significant decrease in H plus concentration. Okay, so these are examples of pH from daily life. You have blood, slightly basic, diba? You have battery acid and hydrochloric acid. Okay? You have lemon juice and vinegar, bleach, basic. Okay? Let's proceed with in preparing acid solution, class, don't forget to add acid to water, okay? It's always A to W, alphabetical. A to W. Okay? It means na kay dapat sa imuhang beaker na kadaay water before nimo i-add ang acid. Dili pwede nga acid unya butangan nimo og water. It should not be done that way. Okay? It should be add acid to water. Okay? Now, let's proceed with buffers. Okay. So, ang role sa buffer class is to maintain pH. Okay? So, an example of a buffer is what it is this bicarbonate buffer system. So, this is the buffer system that maintains the pH of blood. Okay? So, to make buffers class, you have buffer, you have to make it from a weak acid and the conjugate base of the weak acid. So, for example, bicarbonate is a weak acid and the conjugate base is, the hydrogen carbonate is a weak acid and the conjugate base is this bicarbonate ion. Okay, so that is how you make buffer. Dapat weak acid. You cannot make buffer nga gikan sa strong acid. Strong acids and strong bases do not make buffer. Okay, you cannot form a buffer kung gikan kaato. Dapat weak acids and its conjugate base. That is how you form a buffer. Okay, so this is how buffer works. Okay, so the importance of buffer class, as I've said, is to maintain pH, diba? It's to maintain pH in a reaction. So, let's say for example, class. Let's say for example, na ako'y bacterial suspension or bacterial solution. This is my bacterial solution. Okay, so nana dira akong bacteria. And what I want to do is that this is the bacterial cell. This is the bacterial cell. What I want to do is I want to feed this bacteria with glucose. I want to feed this with glucose such that makaproduce ko og cycles. Cycles is a high value chemical. So I want to convert this cheap substance into a very expensive substance. So I will use this bacteria para maoy mo produce. So this bacteria meaning should have the enzyme, diba? It should have the enzyme na makakonvert sa glucose to cycles. So supposing that this bacteria already has that enzyme, when I feed this bacterial solution, so mao ni ang bacteria, nadira ang bacteria. So nadira sa akong solution. So when I feed it, ako ning adan og glucose. If I add glucose to that solution, the bacteria will eat the glucose, diba? Because it's their nutrient. It will be their source of carbon. Now, when the bacteria takes in the glucose, the tendency is that they will produce cycles, and at the same time they will have acidic byproducts, most likely acidic byproducts, diba? Which means that if they have acidic byproducts, they will produce H+, diba? Kay acidic man. And if they're producing H+, it could change the pH of this system, And if ma-change ang pH sa system, most likely, ang tendency ana, it could either kill the bacterial cell, so mamatay ang bacteria, it won't survive in this acidic environment, or ang enzyme ang ma-denature. So dili na makaproduce ang bacteria og cycles because na-denature naman ang enzyme. There's no active enzyme left nga makaproduce og cycles, diba? So this will be useless, diba? The reaction will stop. So the function of buffer class is to prevent that from happening. So, if instead of adding glucose directly, if I add my buffer, so for example, I add this bicarbonate buffer. So, if I add buffer to this bacterial suspension, so giada na nako buffer, and then giada na ko og glucose. So, the tendency is that ang bacteria, magsige siya kaon sa glucose, and magsige siya produce og cycles og acidic byproducts, diba? It will still produce acidic byproducts. But in the presence of this buffer, ang kining H+, ang acidic byproducts nga giproduce sa bacteria will be taken in by this bicarbonate. So mao ni ang buffer system nga kung giadi ba? Mao ni ang buffer. So it will react with this HCO3. So mo-act siya sa HCO3. such that iyang i-consume ang H+. So if iyan ang i-consume, if the bicarbonate, if the buffer consumes the H+, it will not be able to affect the pH of the system. Kay wala man siya H+ nga napuno because iya man gi-consume sa buffer. Now, if in another way, kung OH pa to, kung hydroxide ang gi-produce sa system, if basic pa to ang byproducts, then this H+ would also react with, will consume this hydroxide. Diba? So this will still not change the pH of the system. So that is how a buffer works to change, to resist changes in pH. So a buffer cannot resist the change in pH forever. A time will come nga sa sigig produce og H+, sa kining bacterial suspension. A time will come nga mahurot na ni ang HCO3. So mahurot na ang HCO3 such that no more HCO3 will be able to react with the H+ produced. So, ang result ana is that ma-change na ang pH sa system. The buffer could no longer be used because the system has reached the buffer capacity. So, this is the buffer capacity of the system. Katong time nga nahurot na ang HCO3 na pwede mo react sa H+. Okay? Okay, now, in buffers class, in biochem, what you need to know for, with regards to buffers, you don't need to, know everything because it will be too analytical. So, what you need to know is just this equation. You have the Henderson-Hasselbalch equation, which is the pH is equal to pKa plus the log of base over acid. Okay? So, this is what we call as the Henderson-Hasselbalch equation. Okay? So you have the Henderson-Hasselbalch equation. So, what you need to know about the Henderson-Hasselbalch equation is the terms. So, ang pH class, it's the pH kung unsa imong ganahan i-maintain nga pH. Okay? Ang pKa is the it's the pKa of the weak acid. So, for example, in this case, the pKa of H2CO3. Okay? Now, you know nga ang blood pH is 7.4, di ba? It's 7.4. So, ang pH could be 7.4. It could be the pH that you want to maintain. And then the pKa, it's the pKa of this. Which means that you know this and you know this. So, since you know those things, you only need to compute for the concentration of the base and the concentration of the acid. Meaning, ang concentration nga imong ganahan i-prepare. Okay? So, you don't need to know the exact nga concentration sa base or the exact concentration of acid. You don't need to know that. What's important is you just need to know the ratio of base over acid. Ang ratio ra nila, not the exact na base, not the exact acid. So, as long as the ratio is correct, then that is correct. Okay? Kung unsa ra ang concentration niya, kung unsa ra ang concentration niya, that will determine the buffer capacity. So, kung daghan imong base ug acid nga ibutang, then dako po diyang buffer capacity. Okay? Kay daghan man ang mo react. Okay? And then, remember that this is plus log of base over acid. This is also the same as pH is equal to pKa minus log of acid over base. So, this is kanang logarithm ni sila nga logarithm nga kanang manipulation. So this is how you manipulate log man. If negative na siya nga log, then you just invert that. Positive na sa na siya nga log. I-invert na nimo. Okay? So these are the same. Okay? So just remember nga if plus log ka, that's base over acid, and if minus log, that's acid over base. Okay? So that's what you need to know in with regards to buffers. Just the Henderson-Hasselbalch equation. Other important nga formulas when it comes to acids, bases, and buffers are atong Kw, which is equal to the concentration of H plus and OH. You have, which means that pKw, you have the pKw is equal to pH plus pOH. So you have pKw, because constant man na, so this is always 14 equals pH plus pOH. Okay, so this will determine the acidity and basicity of a solution. Okay, so these are the important formulas needed in acids, bases, and buffers.